Namaskar, Adab, Sasyakal. How are you, students? Welcome back to our series of current electricity. So we have nearly discussed all the topics. Some few topics are that have been left that we are going to cover in the last lecture of this current electricity. That we are in the part 4 of the current electricity. Okay. So in this topic, in this lecture, what we are going to understand, we are going to see about what is in behind me. What do you understand this? What is this device? Actually, it is what? It is actually a bulb. Okay. So we are going to discuss about bulbs. We will be connecting bulbs in series combination, parallel combination, and what is a variety of questions that usually come from there. We are going to discuss about that variety also. After that, what we are going to discuss? We are going to discuss about galvanometer in depth. We are going to discuss about how we can convert galvanometer to ammeter. Why we convert galvanometer to ammeter, that is also a question. We will be converting galvanometer to voltmeter. Then we'll be looking at meter gauge also. So all these kind of devices we are going to study in the last lecture. So are you excited to learn something new? Let's begin to learn. Okay, be ready with your pen and paper, and without wasting any further time, let's begin. So now if I will ask you, tell me what is behind me, what is this diagram? Do you know this? What is this? Actually, I can say this is what? This is a tungsten bulb. And now hello, am I audible? Okay. Here we are back again. There was some technical glitch that usually happens. Okay, so fine. What we are discussing that these days usually we are using what kind of devices, LEDs and this kind of things, CFL bulbs. I was telling you. But if you are going 7 to 8 to 10 years back, these were in the prime use. Tungsten bulbs. This kind of shape was there, and some orange kind of light was coming out of that bulb. So see, what was the system? Some basic things that we should understand. There was always a rating of power and voltage. There was always a rating of power and voltage. Here, like it is given that 100 watt and 220 volt operational voltage is written here. And some inert gases are filled inside. This is the tungsten filament that actually glows. Okay, this is the glass bulb outer covering. Okay, this is the contact wires. These wires are contact wires, and this is connected with the electrical that socket that is there. This is the foot contact corridor. So this complete is called the bulb. Okay. Now what is the circuit symbol of that bulb? It circuit in, if you want to represent this in circuit, this is the diagram of a bulb. This kind of system you can draw in a bulb. This is the representation for a bulb. Okay. This is about the basics. Now what kind of questions the questions will be coming? Questions will be coming that in which case bulb will be growing more brighter. So always remember a simple one thing. Okay, what you have to remember that whenever the power that will be coming is more power, that when the power will be more, the brighter more it will become. Okay, power is directly proportional to the brightness. Power is directly proportional to the brightness. Let's see how. Okay. See, now this is the rating that is already given. This is not going to judge the thing. Okay, firstly calculate what is the resistance from this rating. What will be saying, what will be judging? Firstly calculate the resistance. How will be calculated? Power can be written as V square by R, the formula that we have seen in the last lecture. From here R I can say it will become V square by power. Here what is V square? V square is 220 into 220 divided by power, that is 100. That means how much it will become? 22 into 22, I guess it will be equals to 4840. Correct? Now it is operated with which voltage? That will be depending on that we will be calculating power. Now we will be calculating powers. Now it depends how we will be writing V square by R. Now what is the voltage that you are applying here? That is going to be applied here, and resistance is always constant. So this way we are going to proceed further. Correct? Now see here, what kind of combinations will be possible? Either you have connected 3 bulbs in series, either you have connected them in parallel, either there is a mixed combination, and you have to tell in which condition which bulb is glowing more brighter. This will be this kind of questions will be coming. So let's start firstly from the series combination. Okay. So what we will be writing? Firstly, what I have told you. Let's suppose 3 bulbs are connected. Firstly, write the resistance of all these bulbs. I will be writing power is equal to V square by R. That means if I will ask you tell me R1, how will be writing? You will be writing V1 square by R1. Sorry, P1, power rating is P1. I will be writing R2, you will be writing V2 square by P2. Then you will be writing R3, that is equal to V3 square divided by P3. Power rating is, let's suppose, P3. These are the firstly, you will be in first step you will be calculating these 3 resistance. Then what you will do? Then you will be calculating what is constant along in them. What is constant? I can say it is a series combination, that means current flowing through all these 3 is constant. I will pick that constant and I will write power. Power will be written as I square R. I is constant everywhere. That means I can say power can be directly proportional to the resistance. That means I can say whichever resistance R1, R2, R3, whichever will be having a higher resistance, I can say power will be more. That means power is directly proportional to resistance, and the one which will be having more resistance, that means they will having more power, that means they will glowing more brighter bulb. Correct? Because I have already told you, always there is one statement that is always will be valid, that more the power will be, the more brightness will be there. Don't get carried away by this resistance, because in parallel combination it will be changing. So better you remember that more power, more brightness, simple as that. Correct? What happened? Parallel combination. Now come to parallel combination. Again, what you will do? First step is what? Mention all the resistance. What you will be writing? R1 is equal to, I can say the voltages are same, that means you will write V square by P1. Here R2 you will be saying V square by P2. Here R3 you will be saying V square by P3. Correct? Now what you will say? Power what is common between them? V square by R. That means here what I can say, according to this formula, power is inversely proportional to resistance. That means the more resistance will be, the less power will be. If the power is less, that means I can say the brightness is also less. That means the more resistance will be, the less brightness of the bulb will be. This is, I can conclude from this relation, that power is inversely proportional to resistance. Correct? Now we have discussed this this was the only variety of question that comes from power section, bulb section. Now we will enter into the device section, and first thing we have to understand is about galvanometer. What is galvanometer? Galvanometer is a device to measure a very small amount of current. Galvanometer is a device that is used to measure very small amount of electric current, usually in the microampere or milliampere in the electric circuit. This is a galvanometer that is represented here, and you can say this is the needle. At this moment there is zero deflection. That means the current detected by the galvanometer is zero. Who invented it? There was a scientist, Hans Christian Ørsted. Observed that the current carrying the conductor behaves as a magnet, and he actually defined a galvanometer. What is the internal mechanism? We will be understanding more better into the moving coil galvanometer is there, concept of in magnetic field. There will be understanding about this. Okay. As of now, just understand, if there is a current, this meter, this needle will be showing deflection you in the galvanometer. Okay. So some basic properties. The first property that you have to remember, for the cases also, 10 milliampere of current is responsible for full scale deflection of galvanometer, and this is known as the maximum deflection current. Now if you are having a in this wire 10 milliampere of current, Then also this, because this is so sensitive, the galvanometer is a very sensitive device. Even in 10 milliampere it has shown the full deflection. So it doesn't matter now if you are passing 100 milliampere, still it will be showing the full deflection, because the maximum limit till which it can show you the deflection is 10 milliampere. Always remember it. That's why we have to use ammeter, and the questions can be asked from your exam why we usually use ammeter, not galvanometer, because galvanometer measures a very small current. The normal current that is flowing into our circuit, it will not be able to measure that current. Okay, because you can see what is the lower limit, what is the higher limit, 10 milliampere, and you can, if you want to measure more than that, how you will be measuring? That's why we introduce a ammeter. That is the biggest reason that we introduce a ammeter. Okay. So that's why there is a derivation for ammeter. Now what is this ammeter? Ammeter is used to measure the current in electric circuit. Okay, basic same thing. It is used to measure larger amount of current, as galvanometer has limits. I've told you that galvanometer has a higher limit of 10 milliampere only. So if you want to calculate a larger amount of current, that's why we introduce a ammeter. The ammeter is also looking like same thing. It will also show deflections to you, and how we can convert galvanometer to ammeter, that is the thing that from where questions will be asked. So what we do, we always use a shunt resistance. What is the shunt resistance? Very small resistance is connected in parallel with this galvanometer, and galvanometer also have some resistance represented as Rg. Okay, why we use a shunt resistance such that maximum current will be flowing through it and leaving the measure current Ig with the galvanometer. We connect this so that most, and this resistance is very less, so that most of the current passes through here and very less current is passing through this galvanometer, and the current that is passing through galvanometer is Ig. Now what I can say from here, that let's suppose whatever the potential difference will be there, V1 minus V2, it will be same for both them. Let's suppose name these points A and B. Okay, A and B. So I can say Va minus Vb will be the potential difference for both these shunt resistance and galvanometer. So what I can write? What is the potential difference I can write across G? What is the resistance I? What is the current I? What is the resistance Rg? So I will write Ig into Rg is equals to, because potential difference across both of them is equal, because there is a parallel combination. And what is the current, net current flowing through the circuit is I. Ig is passing from here. That means what is the current passing through the shunt? I minus Ig. I will be writing that. What is the net current? I minus Ig into shunt. That means what is the formula that will be getting for the shunt? Ig Rg divided by I minus Ig. This is the formula that you will be getting for the shunt resistance. This is the formula that you will be getting for the shunt resistance. Is it clear? Correct? Here the diagram is also shown. Here is the formula. Shunt resistance is equal to Ig into G divided by I minus G. All these derivations I have shown you. Now what about resistance of an ideal ammeter? Always remember, for an ideal ammeter, resistance R will be equals to tending to 0. Okay, this is the condition for an ideal resistance. Resistance of the ammeter will be equals to 0. For an ideal ammeter, resistance is 0, that I have told you. For shunt resistance of an ammeter is given as A is equal to Ig into Rg divided by S plus A. Since S is parallel, so S will be tending to 0, so that Ra is equals to tending to 0. Okay, so this is the case for ideal ammeter. I've already told you the results. Now the next important device that you have to understand is a voltmeter. Now same like a ammeter, what is the property? From the name itself it is very clear that what is the use of voltmeter. Voltmeter is used to measure the voltage potential difference across anything. Okay, this is the use of voltmeter. So how you will be using voltmeter? Here it is again a kind of deflection meter. Here it is shown, and it is always connected in parallel through the across which you want to calculate the potential difference. Voltmeter is used to measure the potential difference across an appliance. Voltmeter is always connected parallel to the appliance. That is the point that I have told you. Okay. So conversion of galvanometer to ammeter. Let's suppose I have a galvanometer, and if I have to convert into a voltmeter, how will be converting that? This time I will be joining a very high resistance along with the galvanometer in series combination. This time I will be connecting in series combination. Here maximum potential difference across the galvanometer is Ig into Rg. Since maximum high resistance is connected in series with the galvanometer, that is what exactly I have told you. Okay, if I will tell you about the diagram, this complete thing is called as a voltmeter. This complete thing is called as voltmeter. How you will be writing for that? Now see, what you will write, voltage across this one. You will be writing here what is the current flowing Ig. That means what is the potential difference. If I will be writing, I will be simply writing here I minus Ig into R across this resistance R. Okay, and what I can write about the potential difference across this one, this will be equals to, if I am taking this point as A, this point as B, this point as A, this point as B. Okay, here what I will be writing, I will be writing minus of Ig into S minus Ig into G. That means not take I common from there, what you can say, V is equals to Ig common, and minus you can take common, it will be G plus S. This will be the potential that you will be calculating. Maximum potential difference that can be measured in the voltmeter is Ig G plus S. Ig G plus S, correct? This is a formula that you have to remember. Now the next one is meter bridge. Now why we use a meter bridge? Meter bridge is a device, maybe in your college practicals you have seen a meter bridge. Okay, so what is the use of meter bridge? If I am talking about, meter bridge is actually used to find an unknown resistance. Meter bridge is used to find an unknown resistance. And now what is that unknown resistance? Here, electrical instrument used to find the value of unknown resistance. This is the unknown resistance, okay, and this is the known resistance connected here. And then there is a term here, here it is a galvanometer, and here it is connected by a wire. Okay, it is connected by a wire. Now this wire also having some properties. Okay. This complete practical setup is available in your college. Ask your college and go into college and please watch and do the practicals. This is an alloy of manganese, constant on nichrome. It depends. Length is always 100 centimeter. It have a uniform cross section, and it having a uniform resistance also. That means if I will define a term, resistance per unit length, that is constant. Let's suppose represent it as lambda. I will be using this term very often in meter bridge. That's why I'm telling you in advance only. Resistance per unit length. Okay, so that will be constant for this one. Now tell me, electrical instrument, I have to calculate this unknown resistance. How will be calculating? That is the question. There is a known resistance, that is S. Okay, so now see how we will be calculating. This will be like a, now see, where firstly, what is the first step? We always firstly find the null point. We always firstly find the null point. What is this null point? Null point where the deflection will be going 0, where the deflection of the galvanometer will be going 0. Now what is the meaning of the deflection of the galvanometer will be going 0? That means what I can say, that the net current flowing through the galvanometer is 0. I have to identify firstly a point. I will be moving this jockey. This is called as jockey. Okay, I am moving this jockey, and I will find firstly that what is the null point between this 100 centimeter of this complete radius. Let's suppose now I have founded a distance at this point. Let's suppose this is the null point that I am getting. Okay, at this point D. I will mention the distances. Let's suppose this distance is L1, this distance is 100 minus L1. Of course, the total distance is 100. This null point means what? If this point is at potential, let's suppose some x, that means this point is also have the net potential as x. Correct? And this is a galvanometer. This is one resistance. I can say this portion will also have some resistance, and this portion is also having some resistance. Now, is it not looking similar to something? Now you tell me what it is looking similar. Do you remember any case that we have discussed similar, very much similar kind of thing? Correct. If anyone remember, two resistance in upside, two resistance in downside, and the middle resistance R5 or the galvanometer current passing through that is 0. Can you say this combination is already we are studying, and this is nothing but what? Wheat-stone bridge. Exactly. This is the kind of combination of wheat-stone bridge. Dekho, try to observe. Man ki aankhon se dekho, you will be watching. Okay, man ki aankh is you, for understanding physics, you always have to keep open your man ki aankh. Okay, so that you can understand the things in imagination only. See, here if I read all this diagram, this will be a kind of junction. From here, this is the resistance R that is shown. From here, this is the shunt that is shown. From here, this is the resistance of that section L1. And from here, this is the section that is of the resistance 100 minus L1. And this is the galvanometer This is a galvanometer whose current that is flowing is equals to 0. Can you say, isn't it a Wheatstone bridge? Correct. And what is the property of balanced Wheatstone bridge? And it is a balanced Wheatstone bridge because the potential at this point and potential at this point is equals to 0. Or I can say in other words that the net current flowing through this section is 0. That means I can derive the section, derive this thing. How I will be writing? If I have some other page, let's derive here only. Okay. So I can say I have drawn the diagram. Again, I will be drawing it. This was one relation. This relation is given as R. That is, we have to calculate. This is S. This is one relation. This is L1 due to this is 100 minus L1. And what I can say, the resistance R divided by the ratios of this section should be equal to the ratios S divided by, because the ratios are equal in Wheatstone bridge. Now tell me how you will be writing this resistance. Okay, you remember that I have defined a term resistance per unit length, a lambda. Lambda is what? Resistance per unit length. If I have to write the resistance of this section, how I will be writing? I will be writing it lambda into length. What is the resistance? I will write lambda into length. What is the length of this section? I will say L1. What is the ratio? L1. If I have to write the resistance of this section, how I will be writing? Resistance I will be writing again lambda into what is the length of this section? I can say this is nothing but 100 minus L1. So can I say lambda will be simply get cancelled out, and what is the final result? That remember that R divided by L1 is equal to S divided by 100 minus L1. From here, can I say all these values are given? All these values are given to you, and you have to calculate what finally this unknown resistance R. This is what only you have to do. Just connect. You can calculate the by putting the value, all the values. You can calculate easily what is the resistance that is going to come. Is it clear? Here it is the same derivation that we will be providing you. So finally, we have also completed the massive and biggest, one of the biggest chapter, highest weightage chapter of PU2, that is current electricity, successfully in complete depth. We have seen a lot of varieties of things, and same way we are going to very soon start from the next lecture. That is, we will be entering into the second portion of PU2 syllabus, that is magnetism. Yes, students, that is also a very important part of, if I am talking about any competitive point of view. Then we'll be moving to optics, then we'll be finally moving to modern physics as well. So until next time, keep learning, keep growing with tapasya, endigu and then digu namma tapasya.